My name is Dr. Richard George from the Department of Agriculture and Food. This first presentation is about the extent and trends of dryland salinity in Western Australia. We'll start off with a presentation that describes how salinity's changed over time, and then we'll move on to a conversation about what forecasts for risk there is into the future. We'll also cover some of the variation in processes that happen across the region and the wheat belt, and also talk about how those trends and how salinity extent will differ across the region and wheat belt. Dryland salinity extent, risk and hazard. Across the wheat belt there are various forms of dryland salinity. It ranges from, on the left, mild salinity where crop production is affected, to the top right where you see extensive scalding and land that's been salinised for some considerable time. You also see there the depth and the shallow water table which is driving. The other form of salinity which is common across the wheat belt relates to the lake systems, where salinity has changed from being a lake system which was not particularly saline to one which is now extensively degraded. Dryland salinity is caused by extensive clearing. This shot shows you a presentation of the extent of clearing across the southwest agricultural area. Salinity evolved soon after clearing, 20 to 30 years in the high rainfall country, and in the lower rainfall country it's still active and developing. 24 million hectares of agricultural land sits across the southwest agricultural region, of which about 19 million hectares have been cleared. Clearing started in the 1900s and only finished in some eastern and southeastern areas in the 1970s and 1980s. The majority of clearing was done post the First World War and the Second World War, so there's still a considerable time lag between when the clearing took place and when land salinity is beginning. The result of clearing obviously changed the water balance. There was a lot more water moving around both over the soil and into the soil, and there was a lot less evapotranspiration from the forest that had obviously been cleared away. The result of that is seen in this particular diagram, which comes from between Kojonup and Boyup Brook, and it shows one of our monitoring bores where groundwater trends have been recorded since 1990 through to the present day. You'll see that here groundwater levels started around about 10 metres when we picked up the monitoring. This particular site was cleared in the 1950s, so it had obviously been rising for some time before we installed this particular bore. Over time that water level has risen from 10 metres in 1993 to be now at the surface or near the surface from about 2005 onwards. The diagram and picture at the bottom of the right just gives you an indication of the depth of water table, and this particular bore is installed near a lake with a significant amount of vegetation sitting across it. Over time, farmers have answered questions about the extent of salinity, and there have been a few other techniques. We'll take you through first the farmers' census results that have been collected since the 1950s. The Australian Bureau of Statistics have asked farmers questions about how much salt-affected land they've had, and farmers have responded in their census. The first census was done in 1955, and you can see there's been several since. In the early days, the farmers tended to the responses came back that there was of order of 40 to 50,000 hectares of salt-affected land in the mid-50s, and as you can see, slowly over time through to the 1980s it began to grow, and since the 1980s it's grown at a more increasing rate, and the last ABS survey showed the extent of salt-affected land sitting at around about 933,000 hectares. Also noted down the bottom that the very first extent of survey, a salinity survey, was done by George Burville, and that reported only 40,000 hectares from his estimate. So you can clearly see over time dryland salinity has continued to grow, and at the last count in 2002 there was no rate of slowdown in that rate of growth of salinity. It wasn't the only estimate of salinity that's been conducted over time, and here's 4 or 5 others that I'll quickly take you through. One of the earliest extents was done as a result of a parliamentary select committee in 1988, and it estimated the current extent at 253,000 hectares, or 0.253 million hectares, and that was the first survey that ever had a go at trying to estimate how much land was out there that may have a salinity problem in the future. And here and throughout the rest of this talk, we'll refer to that as salinity hazard. And the sum of all that worked out to be about 2.5 million hectares of land that had some potential hazard in the future. In 1996, hydrologists across Western Australia were asked to combine multiple techniques to estimate the extent of salinity. At that stage, by the early 1990s, there were a significant number of catchment groups that were reporting salinity. The geophysical surveys that had been completed. The earliest satellite data sets were starting to be collated for small parts of the wheat belt, and they're also the beginning of the groundwater monitoring network that we now use or rely on for the future hazard estimates. In 1994 and 1996, when it was published, the estimate of existing salt-affected land, and that was all salt-affected land, including land that was showing a yield reduction, not just the bare saline land, was estimated at about 1.8 million hectares. The area at hazard, which was essentially pretty much the valley floors of the wheat belt, was recorded at 6.1 million hectares. In 2000, there was a national assessment using the same methodology across all the Australian states, and it changed the methodology from that previously used to being an estimate of where water tables were less than 2 metres or 2 to 5 metres and rising, and that was lumped into the extent catalogue, and you can see there that that's an estimate of 3.5 million hectares, and the hazard estimate was all land where the water tables was 2 to 5 metres and rising, 5 to 10 metres, and where there was some expectation that that water table would come to near the surface in the future. And you'll see there that the earlier estimates of 6.1 and the National Land and Water Resources Audit estimates of 6.5 are very similar, just based on a slightly different geography of the valleys of the wheat belt. More significantly and more recently, the Land Monitor data set, which is our satellite-based data set, which is collated for the 20 odd million hectares of the wheat belt, for which the satellite overflies obviously all of it, and counts up all the 25 metre by 25 metre pixels, which it classifies as being either bare saline land or land which has vegetation on it, which is being degraded. Its area mapped salinity at 0.927 to 1.182 million hectares, or around about 1 million hectares, and the difference between those two numbers is areas of farmland where there's a permanent water cover or where there are lakes. So we use the 1.18 as the maximum, obviously. In terms of hazard, it used a different level of surveying data from contour data to map within the valley floors areas that were lower relative to the base of the valley, and areas that were slightly higher, still within the valley, but up towards the flanks. So the range of hazard changed to be 2.3 to 4.3 million hectares, depending on the elevation of the landscape within the valleys itself. So there was very little area of hazard outside the valleys, except for the high rainfall areas west of the western wheat belt, and west of the what we call the Meckering line, which runs, if you like, west of a line that runs from Wongan Hills down to Katanning. In terms of the area of exactive farmland affected, so that's excluding all the public lands, the native remnant vegetation, the reserves, to the end of 1996, when both of the Land Monitor statistics were completed, so while the work was published in 2000, the stats are actually 1996, it records 0.745 to 0.839 million hectares of salt-affected productive farmland. So that's farmland in open arable areas. And it reported the hazard area on farms to be 2 to 3.8 million hectares. Alright, so let's just look at an example of how the Land Monitor data works, because it's our best and most relevant and accurate data sets for farmers. Remembering that even though it's reliable and we believe that it's a good estimate, it's an estimate based on statistics and probability. So in any particular area, it's generally 80 to 90% okay, and by definition, 10 to 20% of that area is questionable. So just keep in mind that Land Monitor, while it covers every hectare across the wheat belt, it's an 80-20 rule when you're using it. Expect it to be 80% right most of the time. Alright, what Land Monitor does is classifies the land into various different categories, and so what I've done here is just prepared an example for Lake Toolibin. You can see the yellow and orange, or red and orange areas are the areas that are salt affected. But the Land Monitor dataset has two classes of salt affected land, that which was saline prior to 1998 and that which was salinised between 1998 and 1996, which is the red areas. The hazard areas, which we talked about previously, and the hazard areas are defined as all those areas where there is a potential for salinisation, so it hasn't actually occurred. So there's a consequence and a likelihood if, as defined as the hazard classes. And you'll see in that diagram there are different shades of blue, and as I said previously, the lighter blue areas are the less at risk or less hazard areas because they're slightly higher, and the darker blue areas are those in the lower parts of the landscape, and therefore because they're lower they tend to have a higher hazard. The green areas are vegetation, and vegetation that's been affected by salinity versus vegetation that hasn't. And the very white or very lightest of areas, obviously in the lakes, are areas that were covered by water when the satellite went through. So that's a snapshot of what Land Monitor and the hazard data has. But what you'll see behind there is obviously we have the cadastre and the land ownership of all the farms and obviously the public lands. So you can see Lake Toolibin there was obviously an area within the public land category, and all the open areas are obviously farmland. Okay, so when you look at salinity and you start to analyse this extent of it, this is a figure that shows the extent as a proportion of land of salinity across the agricultural area. There are some areas that had no coverage because of their terrain, and some areas like up around north and eastern Merredin that have been actually filled in since this diagram was actually completed. So you'll see for a large part of the yellow areas, farms are less than 10% affected, and obviously the further west you go and the higher the landscape you have, some farms are obviously a lot less affected than that. The 10 to 30% tend to be in the valleys, and obviously the 30 to 50% up around Moora or Wongdon, some areas around Tammin, some of the lower Great Southern. There are some farms that are 30 to 50% affected. So let's just look at that in a little bit more detail. On the database we have around about 11,300 farmers who own property of sufficient area to be classified, and those 11,300 farmers are the ones that have that million or so hectares that we've talked about in the previous slides. But here you can see, looking at some of the farmers have, if down on the lower axis you can see the area of salt affected land per farm, and on the axis to the left you'll see the number of landholders in that category. So there are 12 or more farmers that have greater than 2,000 hectares of salt affected land, but there are 279 farmers who actually own or manage 35% of the land area of salinity in the southern agricultural area. Adding the next category of 500 hectares or more, you can see that there are 1,600 or so farmers who farm or manage greater than 78% of the salt affected land, and there are a significant number, almost 6,000, who have less than 10 hectares. So we can break up those categories by land ownership. So let's just sum up the salinity extent. From our satellite data sets, we've got between about 0.84 and 1.2 million hectares up to 1996, recalling or remembering that there are actually no estimates after 1996, and as you saw earlier, we expect the growth to have continued. And while we won't cover it in this particular slide, we believe there's probably between 200 and 500,000 hectares of additional salinity out there. In terms of farmers, the ABS stats reports almost 933,000 hectares in 2002, and that's what farmers report back to us. So those numbers between satellite and farmers are pretty similar. The hazard area is an estimate, and it's estimated to be between 2 and 3.8 million hectares. The actual risk within that zone is a consequence of really what the groundwater levels and climate does in the future, and what land use takes place in those areas in the future.